Welcome to part 2. Part 1, we talked about adding radicals. Here we're going to talk about multiplying. So one type of question that we're going to want to answer, if I have the square root of x times the square root of x, what would that be? So I got two rules for you. When there's no base, when the base has no exponent written, the exponent is 1. When the radical has no root, the root is 2. For example, if I have the square root of x, another way to visualize that is the second root of x to the first power. Okay. Just something to keep in mind here. So let's look at an example. If I have the square root of 7 times the square root of 6, another way to think about this is the second root of 7 times the second root of 6. What we can do actually is multiply the bases. So I'm going to take this 7 and multiply it to this 6. So that's how we combine these. This will be the second root of 7 times 6. And from there we can combine that. 7 times 6 is 42. So the second root of 42. So there we go. So when we're multiplying radicals, we're actually multiplying what's underneath. When we added what's outside. Here we're going to multiply what's underneath. And there's a quick rule here. Notice here we have the third root of 4, and then this would be the second root then of 4. So the rule is, in order to do this, the index have to match. So we actually can't do this second problem here because this has an index of 2 and this has an index of 3, and then this has an index of 2. We can't do these problems, at least not yet, not with the tools that we have. You will one day, but just today is not that day. So let's get in then to how we're going to do this problem. If I have the second root of x to the first power times the second root of x to the first power, this is equal to the second root of x times x, which is equal to the second root of x squared. Now I want to hold on for 1 minute here. I'm going to kind of erase some of my work so we could just focus in on this here. We learned in 1B how to rewrite this as an exponential form, where you take the base, which is x, and then you raise it to the power over the root. Real quick, 2 divided by 2, it's something we can reduce, right? 2 divided by 2 is 1. So this is x to the power 1, which is actually just x. So that continues actually. Here we have the second root of 5 times the second root of 5. So this is actually going to be the second root of 5 to the power 2, which is 5 to the 2 over 2 power, which is just 5 to the first power, which is just 5, right? So these radicals are almost undoing each other, right? If you multiply the same radical by itself, it leaves you with just the base. So here's kind of another way to think about this. Here I have the square root of x, square root of 8 times square root of 8 times square root of 8 times square root of 8. What I could do is I can multiply all the insides. So I have 4 8s, that's 8 to the 4th power, which will give me 8 to the 4 over 2, which will give me 8 squared. Or you can look at this as 8, because these two combine 8 and these two combine 8, so then 8 times 8 is 8 squared. So the rule is, multiplying radicals, multiply the inside if the roots match.